all the other factors in your hive. Sorry, I'm just going, okay. And then that led on to a couple of the hives we had did some really weird things. Most of them had top and bottom vents, but one of them had only lower vents. And all of a sudden, like the bees would do some weird things that we didn't understand. So that led on to a ventilation study last year to look at lower the difference with different kinds of venting. And then we're continuing that this year. So let me take you through some of the highlights or what I think are some of the most interesting things. So the first one was the RAP study. So what we did was we had beekeepers, the New Hampshire beekeepers bought some broodminder sensors, and a few of us had broodminder sensors already. And we had beekeepers in different parts of the state instrumented their hives. And all of our hives had bottom boards closed and lower entrances reduced. Some people had 2 deep, some people had 4 medium, some people had 2 mediums, 2 deeps and a medium. So they weren't all exactly the same size. And then we all had some kind of insulation on the top, either 1 inch, 2 inch, or 3 inches. And most of them had a small upper entrance, but a couple of them didn't. One thing to note is nobody used quilt boxers or moisture boards or anything like that. We did not add any kind of special moisture system to the colonies. Then what we did is we put in 3 sensors. We put 1 sensor in the middle, as close to the middle of the colonies we had. So if you had 2 deeps, it was right in between deep 1 and 2. We put 1 sensor under the inner cover, as close to the middle of the colony. And then we put 1 sensor actually on the outside of the colony, between the wrap and the woodenware. Okay. And these are the different colonies we had. We had 1 that was unwrapped. We had a couple, sorry, I'm getting over a cold, so I apologize if I cough a little. We had 2 that had tar paper, 2 that had colony quilts. And I don't know if you're familiar with that, but that's a product that has black plastic on the inside and outside, and in between, there's like this very thin layer of foam. It has a R value of 3.7. We had 2 that had polystyrene, 3 that had bee cozies, and 2 colonies that had those colony quilts, but with bee cozies over them. And 10 of the 12 colonies made it through the winter, no problem. And they had the reason they died was because those colonies were really weak going into winter. So they weren't going to survive no matter what you did. 1 colony survived, but had no queen. We don't know what happened to her. And the other thing a lot of people say is, wow, you don't have a moisture system on here. These things must have been so moldy. The reality was that we did have some mold in 4 colonies, 3 of them were mine. But they were all down in the northeast corner and well below the bees. And when we talk about some of the thermodynamics of the hive, I think it'll make sense of why that happened. Okay. So I'm going to kind of back up and kind of go through some basics and a little education, because this is all things that I had to do in doing these projects, and going back and kind of remembering and learning some of the stuff that I don't know if I just forgot or never really knew. So one of the things with the bees, and we've all seen it when they fly out of the hive in the winter and then they just drop on the snow. Well, that's because if their body gets below, it's 43 or 45 degrees, they go into what's called chill coma, and they cannot move their flight muscles, right? So that's why if you pick up a bee and you warm it up in its hands, it can sometimes fly off, and then it immediately goes back in the snow. The thing I didn't really remember was that if they don't get out of that chill coma within 48 hours, they never can recover from it. So if they end up in a part of that colony where they can't keep it warm enough, that they can never get back, they can never get their flight muscles back, and they'll die. We all know they cluster, and that cluster has layers where the center is the warmest, and as you move away from the center. The thing I had forgotten about, and we know that they keep that outer layer between 45 and 50, so they don't go into chill coma. The thing I had forgotten about was that a lot of research has shown that the harder bees have to work to keep that cluster at those temperatures and stable, it puts a lot of stress on them, their metabolism and the oxidative stress, and it actually can shorten the bee's life. So I think sometimes when we have our bees make it until March, but they haven't been able to raise that brood yet. Part of the reason why sometimes if they've had to work really hard over the winter to keep warm, their life is shortened, and they just don't have enough life left to be able to raise that first round of brood. The other thing is that, and I know there are some people, and I think Jan, you may be doing this. Some people will winter their bees inside at a fixed temperature. And research has also shown that they use the least energy when the ambient temperature outside is 40 degrees. So when we winterize our hives, what we just really want to do is make it easier for them to maintain their cluster temperature, however you do that, and also make sure that any moisture that they generate by creating all this heat doesn't adversely affect the colony. And they do need moisture. They will go off and pull moisture off the sidewalls and things like that. Okay, and I do have a couple sources. I can post this presentation, but versions of this are actually already up online. But there's a couple really great resources that I listed down here, where they talk, or Randy Oliver has a really good series about understanding winter buildup, and also Bill Hespeck has a nice talk about winterizing bees and things that happen in the hives. Okay, so our values. We all know our values, right? We always hear it when we're talking about our house, and we have our whatever in our walls and all that. But again, I kind of had to go back and start to like relearn some of this stuff, because I really, when I thought about it, I don't really know how it works. So our value is the measure of how well a barrier resists heat flow. So heat always wants to go from warm to cold until it's all equal. And what our value does is it just is how quickly can heat transfer through whatever that thing is. And everything has an R value. Wood has an R value, insulation has an R value, honey has an R value, bees have an R value, everything has an R value. So the lower the number, the more heat transfers through, and the quicker it transfers through. So at R1, if you have sun on something that's R1, it's going to transfer through fairly quickly. If it goes up to R2, it's going to still transfer through, but just slower. And then if you stack them together, it's all additive. So if you put 1 and then 2, it just is R3, and it just is a little slower. And like I said, everything has an R value. We calculated a frame of honey. If you had a medium frame of honey, that R value is about 0.25. So if you had your Langstroth hive, and you had the wooden wall, which is an R1, and then you had 4 frames of honey that were full, that would be R1 plus 4 times 0.25. So it would be R2 on the outside. Now, if they eat that honey, then some of that R value goes away. But everything in the hive is going to have some kind of R value. Okay. Sorry about that. And then so, when the bees are in the cluster, in the colony, let's say they're just in the middle, they don't heat up the whole colony, but we know that the outside of this is probably 45 or 50. And since the rest of the inside of the colony is not that warm, that heat is going to start rising. There is going to always be some moisture in that heated air. And you know that warm air holds more moisture than cold air, right? So that's why in the summer you hear people talk about dew point, right? When it's really muggy, there's a lot of moisture in the air, and that cold front comes in, and as soon as it hits whatever the dew point is, it starts raining, because that colder air can't hold as much moisture. Well, the same kind of thing can happen in the hive. If the hot air goes up, it hits the inner cover, which is going to be colder no matter what, you're going to start getting a little moisture that may come up on that. If it gets cold enough, it can rain down on the bees. And this is where people say, boy, you need to do some kind of moisture, because you don't want this to rain on the bees. And that is absolutely true. Now, depending on what you do with insulation, you don't necessarily need to put on a moisture, like a quilt box or a moisture board or anything like that. Because what happens is, if you put really high insulation on the top, like an R15, and put slightly less on the sides, when that comes up, you're still going to get a little bit of condensation at the top. But because you're keeping some of the heat in, or it's slowing, that R15 is slowing the temperature, the heat going out, this air is a little warmer up here. This becomes this warm air pocket. And then as the air moves off to the side, it hits the slightly colder sides, and the water will condense on the sides. So when I was saying before, we had some moisture, like in the northeast corner of a couple of my hives. So it was kind of down in here, if this was the east. And that's going to be your coldest part of the hive. The northeast is going to be always the coldest part if you're facing south. So does this make sense to everybody? Does anyone have any questions? Okay. I'll keep going. So if you think about, you have your colony and, you know, it's a nice sunny day, right? The front is going to get really nice and warm, and that's going to come through the woodenware and your honey and all that. And it's going to start warming up the colony, which is great. Now the backside isn't necessarily as warm, right? Because the sun isn't necessarily on the backside. So you might actually start having some heat go out the back. At night, you have heat going off everywhere, out the top, out the sides, and on a cloudy day, it depends on how warm it is outside. So, you know, it's kind of when you start thinking about this and insulation, you start saying, okay, well, when you put insulation, again, you are not going to stop heat from transferring, but you are going to slow the heat transfer down. So it may be that here at nighttime, if it's cold outside, and I'm going to show you some temperature measurements here in a second. If it's cold outside, you're slowing down that transfer of heat outside. So maybe it makes it a little easier on the bees. Okay. So what do we learn from the wrap study? The first thing, as I've mentioned 2 or 3 times, there is no wrap that prevents heat transfer out of the colony at all. Every wrap is going to, you know, it's not 100% that it's going to hold in the heat. However, higher wraps, but we do slow down the transfer, and I'm going to show you an example of that. Dark wraps, one of the things that people say a lot is, you know, you want to keep something like tar paper and with a low R value because you want that sun to heat up the hive, and that's a good thing. But we also did show over and over again that dark wraps, whether it's a bee cozy over a colony quilt or a colony quilt, this black will heat up a lot, and it does warm up the inside of the hive. If you have straight up polystyrene, it will not heat up that same way, but dark wraps do. And if you get nothing else from this talk, and I think Sam has heard some of this talk before, so she knows this is kind of my mantra now, is gaps matter. If you remember nothing else, pay attention to gaps, because they allow heat to escape and counteract value of all of your insulation. And sometimes when you're doing something that you think can help the bees, having a gap can actually, it turns out, hurt the bees. So like, I'll give you an example of when we added some candy boards, and it turns out that wasn't a good thing. Just one thing I found that was interesting, just to kind of show that heat does go both ways, is if you remember, we said that there was a sensor between the wrap and on the woodenware, between the wrap and the inside. We could actually sometimes see when the cluster had moved over by there, we could see the cluster radiating all that heat out through the woodenware out toward the wrap. So this is truly an amazing thing to me that these bees survived. So this is one of our tar paper colonies, and it happened to be in an area where his apiary was, it was kind of shaded, right? And so these bees, the blue up here is the sensor under the inner cover. And that's what this is. So you can see here that the bees are right up by that inner cover, right? It's at 60 degrees. Okay. Then we have a sensor in the middle, and we have a sensor on the outside on the wood. So this little yellow line here is the outdoor temperature. I forgot to mention, we had a temp sensor in the apiary. So we knew in that apiary exactly how cold or warm it got. So at midnight, it was like 10 degrees, and then it dropped down to about -5 at 6 a.m. And then it got a little warmer. And then the next night, it kind of stayed down around -10 up until 6 in the morning. And then it got a little warm. So let's look at what happened. This gray line is the sensor on the wood. So you can see it followed the temperature right down, and actually on the woodenware went below 0 for a long time, right? So on the outside of the hive, we were well below 0. The orange, which is this middle sensor. So what is that, like 9 inches below because these were 2 deeps, 9 inches below the inner cover. It also was cold and followed it down. Now it was getting some heat off the cluster. That's why it wasn't quite as cold. But look at how it got down to almost 0. So up here is 60 and here is 0. So those bees, and they survived. They were a little weak when they came out of spring, but these bees survived. But they worked really, really hard to keep this stable. And when we started seeing some of these numbers, we were like, wow, you know, we always hear, oh, the cluster doesn't heat up the whole thing, but here's a good example of, you know, we had less than 9 inches below, or definitely not 9 inches below the cluster, that the temperatures were almost down at 0. And just to show you a quick comparison of wraps, I had 3 three colonies in the study. One was a colony quilt, which is R 3.7. One had polystyrene. It was this homemade cozy that I made. It had polystyrene with marine vinyl wrapped around it. And then I also had one with a colony quilt and a cozy on top. So that was R11. So this is a different day than I showed you before. So the yellow shows you the temperature in my apiary. So we got down to pretty cold. These bees and all three of them were at the top the entire winter. And these were the temperatures down about 12 inches below, because I have 4 mediums. So it was down above the second medium. So the blue here is the colony quilt, the one with the lowest R value. So you can see it heats up the fastest, right? And it gets pretty warm. Certainly much warmer than the outside temperature, but it also is the one that falls off the fastest. So it's the one that radiates out heat the most, and that makes sense. It's the lowest R value. The one with polystyrene and the marine vinyl, it's the middle R value. So it heats up slower. It doesn't get quite as warm, but it also doesn't fall off as fast. And then the one at the highest R value, again, it heats up slower because it's, whether the heat is transferring in or out of the colony, it's a higher R value, so it's not going to go as much, go as quickly. So it doesn't heat up quite as much. And again, it doesn't cool down quite as much. So no big surprise here, but sometimes I think it is just kind of nice to see the data. And these colonies are literally right next to each other. So they're getting the same amount of sun from the same amount of sun in the apiary. So just to sort of show you like this heat dissipation, that one that has the colony quilts here, this is how I had it wintered. This little Reflectix thing, one of the things you have to be really careful of with if you are using any kind of insulation on your colonies is you need to make sure the top of that insulation is really tight up against the wood, because if you get rain or snow down in there and it freezes, then that changes the whole R value of everything, and you may not really be insulating your colonies. So what I've ended up doing the last few years is taking that Reflectix and basically stapling it and making like a little shingle over the top so that I don't have to any snow that comes down in. So it was a real sunny day all day. We had sun from 8:30 in the morning to 2:45 in the afternoon. So I went out that evening when it was 15 degrees and I used my little FLIR camera and I took a picture of what this looked like. So I don't know if you've seen FLIR pictures before, but blue and green are the coldest and white is the warmest and red is the next warmest. So right here, that little dot, that's this had an upper entrance, a small upper entrance. So you can see heat is coming out there. All of this red here, this is all heat that's coming that the colony quilt had absorbed and is now radiating back out. Okay, so then I went out 12 hours later, the next morning, when it was actually warmer outside, so 22 degrees outside at 6 a.m., and I took the picture of the same thing. Now you can see there's no more heat that's coming off of this, but we are still getting heat coming out. So you can see that this holds heat for a little while, so it will be transferring it out and as well as into the colony for a little while, and then it's gonna, because it's black, and then it completely gets rid of all of the heat. So gaps matter, and I'm going to show you a whole bunch of examples of this. So my homemade bee cozy, I had polystyrene, and then I had it in like a sling inside this marine vinyl. And frankly, when I made it, I was bored one weekend and made these, and I really didn't pay a lot of attention. This was long before I had done any of this starting learning about the thermodynamics. I just, I'm like, oh, it's there, it's covered. But I really didn't try to make sure that everything overlapped each other. So again, I went out on some cool early morning. I tend to take FLIR pictures early in the morning because I don't want the effect of the day's sun on there. And I was looking down, looking down onto this corner. And you can see here, there's white, and you can see all this heat leaking out. So even though I have R6 here, I'm getting all these gaps. Our heat is just coming off the hive. So again, it's good that I have this, this insulation, but it's certainly not being that effective. So, being careful to make sure that if you do use something like polystyrene or you have different pieces of insulation, make sure they're overlapping to try to make sure that you don't have a lot of gaps is really important. The other thing is I never have bothered. I have all kinds of pieces of polystyrene up in my barn. So I've never really bought the polystyrene that fits under your inner cover. I just went and cut my own pieces that would fit in a super. So my colonies tend to be 4 mediums and maybe a feeding shim, inner cover, and then an empty super with insulation stuffed in it, like 3 inches of polystyrene insulation. So that same day when I took the pictures, I took the cover off just to see where I had leakage. Well, you can see I obviously did not do a very good job cutting my upper insulation. So while I have good insulation on the top, I certainly have heat leaking out all over the place here. And if I had, the ones that you buy are nice and tight, but certainly if you're cutting your own, just be aware of that. So gaps matter. And then the last one, and this is I think an example, and I've done it. I did it the first year, and one of our other beekeepers did the same exact thing the following year. Sometimes, again, when you put something that you think is a good thing on your hive to help your bees, like feed them with a candy board, it isn't always. So I had decided, I'd always used to use fondant. I said, I'm going to try a candy board. My husband made me these, and I said, well, it had been drilled into my head. You got to vent, you got to vent, you got to vent, because it can't rain on your bees, right? So I was like, I better have him cut a little hole and make a vent in here, because if I have candy board, it's going to be all sugar. It's not going to get good venting. So he better do that, right? And then so he just made me this shim, and then I stapled hardware cloth to the bottom of it, right? Pretty standard thing. And this hardware cloth is 1/16 of an inch. So this was the other person's colony that basically had the same kind of candy board, slightly different, but same kind. So he had, the bees had been doing really well. They were hanging out here. They were at the top of the colony, hanging out at 60. He put on the candy board here, and look at the big drop and how low they were having a hard time, because basically the hive got over ventilated. And what happened is that he had the vent hole, so it was get that gap, the heat was coming out of that, and then the little gap here where this 1/16 of an inch, you don't think it's that much, but heat was pouring out of that. Okay, so what happened was he pulled his insulation up over it, and basically the bees recovered and had no problems. But things like that, again, not something I had ever thought of. So now what I do on my candy board or any kind of shim is I actually put a piece of weather stripping, that foam weather stripping you buy at Home Depot that you stick on. I actually put that there. So that seals any of those cracks. And sometimes the bees will chew at it a little, but I really haven't had a big problem with that. So that's the kind of the big highlights of the RAP study. Do you guys have any questions or comments? Okay.
I have a question.
Oh, hey, Starsha.
Hi, how are you? So in a couple of your images, you had it looked like the base of your hive, like what you were setting the hive on,
Yeah.
was wrapped. Yeah, at the bottom there. Can you
Yeah.
tell me about that beneath the hive wrapping?
Oh yeah, sure. Sorry, good catch, Sarsha. So what I have here is the back behind this is like a field with a big hill, and the wind comes down the hill, even though I have like witch hazel and all this stuff behind there. So I have what this is my bottom board sits on some cinder blocks that are all leveled off. My bottom board is closed completely with a piece of polystyrene. But then when I started doing this, I'm not sure it really helps, but I just had a bunch of Reflectix. So all I do is I just wrap it around the bottom to help prevent any wind from coming in that maybe, my polystyrene, because I'm not always, as you can see from this picture, the top insulation, I'm not always perfect in how I cut it. So what I do is I just take a piece of Reflectix and wrap it around the bottom and put a bungee cord on just to help prevent some of the wind coming in. Does that make sense?
It does.
Okay. Any other questions? So, and one of the comments I want to make, I am not advocating like that this is the kind of way that you need to do your hive or how you wrap your colonies, because the big thing from all of this is that trying to understand, even though, think about a little bit about, and we're going to talk about airflow next, about airflow and the insulation and things like that, because it's really this gigantic balancing act, right? Of how much airflow do I have? How, where is the moisture? How much insulation is where, how is that moisture going to move around? Because like A.T. Tardif, who did consult with us on this, he keeps his bees a totally different way up in the Yukon, right? He has what's called the condensing hive. So he has just a bottom opening. He keeps his entire bottom board open, but he builds like this insulated cellar around the bottom. And so he has a totally different way of keeping his bees and very successful. But again, it's a big balancing act. So that's the trick, is to try to find all of that. Okay. So then the next year we did some ventilation studies. So this is my setup, and you guys kind of already have learned a lot about it's the sort of basically the same setup as before. So here's the base that we just talked about. And then what we did here, I think I've actually got, so I have 4 mediums. I put on a shim for feeding, and I have my weather stripping in there. I actually don't use those candy boards anymore. Then an inner cover in either depending on which colony, because we're comparing upper and lower vents to just just a lower vent. So it was either open or closed. And then I had 3 inches of polystyrene insulation up in the top, and the screen bottom board was closed. I don't personally have a lot of experience with slatted racks, but I know a lot of people love using them and swear by them. So I said, well, when we're going to do this ventilation study, there were 5 colonies. I'm going to put I want to put slatted racks on to see what I can learn about slatted racks. And then the other 3 didn't have slatted racks. The 3 of them had a bottom opening and a top opening. For those, and this is, I had show and tell, and it's too bad it's snowing, but the inner cover, what I did was I took a piece of, I basically took a milk carton and cut strips of plastic and made basically this little wind block. So it just kind of goes over the top of it. And so the bees can come out, but it helps from just, if wind reverses, you just don't want it to come in the hive. And then other ones had the top blocked, and we had a slightly larger bottom opening. And then we had 5 broodminder sensors in here. So we had 2 north and south in the middle of the hive, and then at the top of the hive underneath the shim, we had the north and south, and we also had one over on the east. And 4 of the 5 colonies had bee cozies, because the other one didn't, because I didn't have bee cozies. So I just wrapped it in 3 of those colony quilts. And then I did that shingling thing. And then, this is a bungee. I call it the Hollister bungee. Melissa came up with this method of creating a bungee that is the best way to be able to put it on and hold your wraps on tightly. And again, I'm sorry that I can't be there in person, because I brought some with me just so you can see what they're like. But everybody who was in the wrap study got some of these, and they all most of everybody went out and made their own after. So, all right, so let's talk about airflow. So airflow is something, air moves like water. It wants to go to the easiest place. And remember that heat, right? Whenever you have a warm area, it wants to equalize and move the cold. Well, when that heat moves, it creates air currents, right? So if you just have an empty box and there's a cluster in here and heating, the heat's going to move up. If there's a vent at the top, the heat's going to go out, and it's going to have to pull heat in from the bottom. That's how your wood stove works, right? That's called the chimney effect. Well, and that's great. But now if you add a slatted rack for, hopefully you guys know what I'm talking about. It looks like this. And basically there's about a 4 or 5 inch solid board. And then there's slats like this, right? So, well, the air can't go up through that slatted rack. So it has to divert around it, right? Now, if you add a cluster in here, now you've got bees, and depending on how tight that cluster is, some air is going to go through it. Plus they're going to fan, and they're going to start moving air around different ways. And then we add in our frames, and depending on where your vents are, if they're in line, well, you kind of maybe have a straight up path right up to the top, but you're also going to get diverted between the frames. And if they're not lined up, which might never are, not intentionally, they just never are, you're just going to have airflow all over the place. So the bottom line is predicting airflow and ventilation in a colony is really complex. This is really a computational fluid dynamic problem. And some of you, I don't know if you follow BL Forum or read any of the B magazines, but there's a gentleman, Derek Mitchell, Dr. Derek Mitchell from Leeds, UK, who is a mechanical engineer who has expertise in this. And he has been doing studies and modeling this kind of stuff. And he's just kind of flipped the B world on their, gotten a lot of buzz lately. Because he has been starting to say, you know, we need to really rethink in doing this modeling. He's starting to learn more about how ventilation works and that what we think may be insulation of the cluster is really more of a heat sink. So bottom line is it's really complicated to figure this out. So you can't really just kind of guess. But what we can do is we can measure temperature and relative humidity. And it would be really nice if we could put an anemometer in the hive, but we obviously can't do that. But we can use temperature and relative humidity because when air moves around, it starts dispersing the temperature, right? And it disperses the moisture. So we can kind of infer how well our ventilation is working. Okay. So just one more example, because one of the things that always confuses me, and this has been 4 years now, I've been doing this, and it really is hard for me to look at relative humidity. I can look at temperature and go, yeah, this is what's going on. But relative humidity is a measure of how much moisture is in the air at this temperature compared to how much moisture the air can hold. So if it was 50% and the temperature goes up a degree, even though no more moisture is in the air, the relative humidity can drop because that air could hold more moisture. So I always get really confused by this, and I'm going to give you an example and maybe it will be helpful. So last year, Melissa and I started looking at this measurement called, this calculation called vapor pressure deficit, which combines temperature and relative humidity. It's just a pretty straightforward equation. And it tells you how much room is left for water in the air. And we're finding that as an easier way to be looking and trying to understand how things are moving around the hive. And I'm not going to get into this whole VPD thing here, but I want to mention it because in the future, if you hear it, I think it's important to at least, know a little bit about what it is. And the other thing is that we always know warm air can hold more water vapor than cold air. But even if it says we're completely saturated at 100%, it doesn't necessarily mean there's condensation. So there's a lot of stuff I just talked about. So let me give you an example. So let's say we had this beaker, this volume of air, right? And it's at 68 degrees. And at 68 degrees, that air can hold up to 14 grams of water vapor. But there's only 7 in it. Those are what the 7 blue dots are. And the empty dots are this is the space. So if we want to figure out relative humidity at 68 degrees, it's 7 grams divided by 14. So it's 50%. And VPD is just a calculation. So we'll just skip that. But it's a number over 1 means there's a lot of room for more water. It can get water. Now, if we cool that same thing down, just drop the temperature down at 50 degrees. At 50 degrees, we can hold 7 grams of water. We haven't changed how much water's there. There's still 7 grams of water vapor in the air, but our relative humidity now is 7 grams. It can only hold 7 grams. So our relative humidity is 100%. But it can hold it as long as we don't cool it anymore, or as long as no more water comes in, it's still all in the air. And the VPD, there's no more room, so the VPD is 0. So then if we cool it to 32, well, 32 degrees, you can only hold 3.5 grams of water. So those other 3.5 grams water vapor, those other 3.5 grams have to go somewhere and they condense out and become water. So at this point, the relative humidity is 3.5. I'm sorry, relative humidity is 100% still and the VPD is 0. So, just because it's 100% doesn't necessarily mean we have condensation. So don't worry if you don't totally absorb all this. But I do want to bring it up because I think, as people look at more things, these are important concepts to at least have a basic understanding of. So one of the things we came out, and this is all up on the website, and I'm not going to go through this, but one of the things we've tried to do is come up with a table for those who do instrument their hives so that you could try to take and understand the relative humidity and look up the relative humidity and whatever temperature and for your winter clusters and kind of figure out maybe what's going on or infer some of that. So if you're in this area of the blue, you're really far away from the cluster. And maybe you may or may not have condensation present. If you're in the yellow area and it's December to February, you have a cluster pretty close to the sensors. If you're in the red area, then you've got brood present. So I'm not going to get into this, but this is something, and we've been trying to use this, and the project we're doing this year is going to try to refine this. Eitan Tardif also is doing work around VPD, and we've been comparing notes with some of the stuff he's been doing. So what we observed about insulation, and we kind of just talked about this earlier about gaps matter, but too much airflow makes those bees work harder. No question about that, to be able to keep things stable. And it may shorten their lives because we know the harder they have to work that it can shorten their lives. They will do what they need to in order to manage their environment. And I'm going to show you an example of something I had last year where the bees created their own ventilation for themselves. And then they did a really good job. They've always done a really good job of controlling moisture and humidity in the hives. You can see how tight these hives are. And I have no moisture systems. The ventilation I have is all very small. And I do sometimes have mold in the northeast corner down in maybe on frame 10 or frame 8, but very, very small. And then sometimes I don't have any. So this is just another example. This is my example of mine when I had that candy board here. So let's see, what do I have? The outside temperature is the orange. The blue is up the temperature under the inner cover. So you can see these bees are having a really hard time keeping warm, right? Melissa's the one who's like, you got to go block that candy board entrance. So I blocked this hole right here, and you can see they start getting it stable, but they're still pretty cold and having a hard time. And then I ended up reducing because at this point I couldn't put anything for that gap. I ended up reducing this upper entrance. So the upper entrance was almost closed, and you can see that started recovering from that. So the gap, it ended up counteracting some of the gap. So just another example of gaps matter. So one of my colonies last year created its own entrance because it really was not happy with the ventilation that I had. This particular colony had only a bottom, I had a large bottom entrance. It was about 1 3/4, I think, something like that. It had no upper entrance. The shim had a hole that came in it, but I filled it with that spray foam insulation stuff. So this blue line here is the sensor on the south side in box 2. So you can see that the bees up until about December 3rd were right around that south sensor. Then for some reason, they moved right up to the top. And I'll tell you, they were really loud. I went out to check something and I could hear these bees. I'm like, what the heck are they doing? But, and they moved up. There was all kinds of food down here below the bees. And then all of a sudden they ended up being over here. Right. And I was noticing all of a sudden I'm seeing bees come out the top of, and where there should be none. I thought they must have eaten out the little piece of polystyrene, and they hadn't. So what they had done, oh no, is this not? No, there we go. So what they had done is they chewed out all of this spray foam insulation, and they decided that they needed their own entrance up here. My theory is that, oh, that's why these became one. My theory is that I did not have a big enough vent down here for the air to be able to move around it because of that slatted rack. It kind of slowed down all the airflow, and they were having a really hard time controlling the airflow. So they said, well, you know what, we can make our own upper entrance, and created a change, completely changed the airflow in this colony. They did not survive, but I had nothing to do with this. I believe they ended up in November, they had some crazy high mite count, and I did treat them, but they just dwindled. And by April, they were dead. So I don't think it had anything to do with this, but they did go and create their own entrance. So they will modify the colony if they think they need to. So again, If I didn't have a slatted rack on there, would they have done this? I don't know. The colony right next to them was set up exactly the same way, but no slatted rack. And those bees stayed right in the middle of the hive until April. So I'm not sure, but it does make me a little suspect. The other thing is that bees don't always cluster where you think they're going to cluster. So this is the over here. Whoops, sorry. I'm pointing at my screen and not using this. This is the colony right next to it that also has just the lower entrance and no slatted rack. And they stayed right here in the middle of the colony all winter, right? And so this is what's called the condensing hive. Air comes in, it kind of hits the top and then goes out along the sides. They were pretty happy. I also have a colony, because of the way my apiary is set up, I have a colony that faces north, and it's always faced north. You're not supposed to make colonies face north, but I can't work the hives unless I do. So this colony also, it has an upper and lower entrance. So its airflow goes like this, but its cluster also stayed in the middle all the time, the entire winter. What do you notice? And I would like you guys to tell me, what do you notice about this? What is there anything odd about that colony that faces north that you can notice? Anyone? Notice that where the cluster is. This cluster over here is on the south side, right? If you have a colony facing north, you would say, oh, it should be clustering on the south side because that's going to be the warmest part of the hive because that's where the sun is, right? These bees never. This is the 4th year, and they've been requeened, but this is the 4th year this year that I've had this colony. They always cluster on the north side. And my theory is they cluster on the north side because they can control the airflow, this airflow that's coming in. This winter, and I'll show you the setup. This winter, I have 3 colonies. They're instrumented with 10 sensors each. So they are clustered between box 2 and 3, right on the northeast side, which is the coldest, you would think the coldest part of the hive, but it also is the part of the hive where they are the closest to where the airflow is. So they're staying in the area where they can control the airflow. So the bees don't always do what you think they're going to do. And let's see. Okay. And then the little thing was about the mold. So in last year's, we did have that one that made their own hole. There was a little bit of mold on the northeast side of box 2. And that's just down here at well below the bees. The one that had, the other one that didn't make their own hole, again, just a little tiny bit of surface mold. I had one that had a top and bottom entrance, but it had a slatted rack and it had a lot of mold. Again, all on frame 10 up on the northeast side, but way more mold than I'd ever seen. And I really do think that I probably needed bigger entrances or something on the bottom when you're using slatted racks. And then I had 2 colonies that had no mold whatsoever. And I could see that occasionally, like not that stalker hive, but my other hive with clustered at the top the entire winter. Every once in a while, for 2 or 3 hours, I would see them dive down and come down here. You could see them come down toward the north side. I assume what they were doing was going down and getting water, and because they needed some moisture. Don't know, but I'm guessing something like that. And, so, in the cases where I had no mold, I'm guessing the bees cleaned it up or they were using that water. But it also probably, it may have been something else. It was probably some combination of the airflow also. So this year, what we have is just the follow on to what we did last year. Same hive setup, although just a top and bottom entrance, but we have 10, they're instrumented with 10 broodminder sensors on the middle of the hive. It's northeast, west, and south. At the top of the hive, northeast, west, and south. And on box 3 on mine, it's east and west. So we'll see what we have. And our goal here is to just continue to learn about this ventilation and also kind of refine that VPD chart. So things to consider, and I know it's too late for you guys for winterizing your colonies now, but it's never too late if you see something that you can actually make modifications, because we've been doing that as we go along. So think about how much direct sun do you get and how strong your colony is, because a weaker colony is going to probably benefit from a higher R value wrap. gaps matter. Where are the openings? Make sure you understand why they're there, and make sure that, think about, are they possibly making the bees do a harder work? They do a good job of controlling their own environment, but you can under or over ventilate the colony. And if you're only using a bottom entrance, I really think part of the issue that I had with why the bees created their own was the combination of, I didn't have a big enough lower entrance. And when I've compared it now to what some other people like Bill Hesbeck and Aiton Tardif do, I think I probably should have had a bigger and lower entrance if you're only using a bottom entrance. And slatted racks may especially need a bigger entrance. And like I said, balancing all these variables is the key. And if you start seeing something that looks a little odd, it's okay to go ahead in the winter and start trying to modify it. But something you think may be helping a colony is actually hurting it. And we have an example, actually. This is our website where everything is. The new ventilation, if you want to look at any live data, that's where this is. We also have put up, we've had several people say are using these broodminder sensors and we'd like to contribute our data. So we set up web pages for those. Starsha's one of them. And we also have some colonies in Portsmouth, and some of Melissa's hives are in there. But we're seeing some of the colonies have quilt boxes on them, and it looks like we're getting a lot of heat escaping from those quilt boxes. And so this is one where we think we're doing something good, but it actually may be hurting the bees. So, because we can just see heat coming out of them and they're not moist. So it may not really be doing what you think it is. But there's all kinds of presentations up online for about the RAP study, all kinds of analysis, last year's ventilation study, and then these two right here are live streaming. So if you want to look and see what's happening, and we will do analysis and all that also as that goes on. And if you remember nothing else, gaps matter. So thank you. Any questions? That was a lot of stuff that we covered.
It certainly was. Thank you so much, Heather, for bringing that all your work, and Melissa. She hopped on.
Oh, she did. Oh, good.
Yeah,
hey, Melissa.
she did.
Excellent.
For all the work that you've done and that you continue to do. It's a lot to take in. I did hit the recording, so we'll send it out to the membership and they will be able to watch it again and reiterate, because it was a lot to absorb in this 1 hour. But thank you.
I do have a question. How big are your bottom entrances when you have just the bottom entrances?
I have to go look them up, but let me quickly look. I want to say they're like a ½ an inch by 3/8 of an inch. Oh, when I have just the bottom entrances, sorry. Let me go grab the right information. I want to say they're like 1 3/8, but what I can do while you guys are starting to do the business meeting is I'll go look up the exact and put it in the chat.
Thank you.
You're welcome.
Thank you.
And I also did want to say, I forgot to put it in here. I'll put my email address in the chat if anyone has any questions or suggestions, or if you are monitoring your hives and you would like to be part of our winter monitoring project, just let me know.
Well, I know Sam just got one.
Yay. All right. I expect to hear from you, Sam.
So that'll be great. Okay, first of all, Happy New Year to everybody. If you've been sick, I hope that you're on the mend. If you haven't been sick, take your propolis. Keep yourself healthy. We are sad that we weren't able to meet tonight, but some of the roads in some of the areas, because we cover such a vast area of membership. Some of the roads, some of them are up to 10 and 12 inches of snow. So I know right here in Whitefield, we've got about 4.5, 5 inches. But I know probably April and Russ, I know you guys must have some more. You don't have 4 or 5 inches.
Yeah, we got about 10.
Yeah, yeah.
Yeah.
So I think it was a good call to keep it online tonight. Oh, where are we here? Next month, we will be meeting the second Sunday, and it will be at the Bethlehem Library. And hopefully we will not have crappy weather again. 2 months in a row of crappy weather has not been good, but we will have our raffle and door prizes and whatnot. I've got some stuff here that'll come out for that meeting. We will probably also do our voting at that meeting because we still have to have some people step up to the plate for some of the positions that are available. So if you want to contribute to the organization and keep us going and keep us afloat, holler, reach out to me. Oh, Heather did put her email in there. So now does anybody have any questions about what's happening?
Nope.
Nope. Okay. NHBA is going to be having their spring meeting. Mary Ellen, do you have that date?
I do have the date, but I haven't heard back from Zach about confirmation that he's coming. So,
Okay.
I believe let me just double check. Is it the 23rd? It's a Saturday. We have Camp Carpenter. And it wasn't going to be, we had originally wanted to have it on the 16th, but I guess that's Maine or Massachusetts is having their meetings. So we changed it. So it's around the 20 something. Anyone have a calendar?
That would be the 23rd. Yeah.
Yep, 23rd. So hopefully Zach Lamas will get back to me. I will give him another nudge.
Well, I'm glad to find that out because that's the last day of our B class. And
Oh,
we had moved it because we thought the NHBA was going to be the week before. So I will have to see if we can change that.
well, we'll see if we can do a Zoom hybrid. Maybe they could attend. Oh, they'll be members. They could attend. No, wait, will they
They
be?
can't attend while they're in class.
Oh, okay. Never mind.
Never mind. So I'm